Hi friends, welcome back to our YouTube channel, one and only pharmacy. So friends, in today's video we see detailed notes and explanation about emulsion chapter, subject pharmaceutics second, the pharmacy second year, presented by one and only pharmacy YouTube channel. So friends, I request you to all, please watch this video till the end. In this video we see detailed notes with explanation. You have to write these notes on your notebook. Let's see. Topics cover under this video. Which topics we are cover under this video? First, definition, emulsion or emulsions. What is emulsion? What is emulsions, etc. Types of emulsion, identification, test of emulsion, emulsions and their classification, methods of preparation of emulsion, instability in emulsion, and HLB and its importance. These topics, following topics are we cover in today's video. Let's see once by one. Definition of emulsion. What's the definition of emulsion? Emulsion is a biphasic dosage form. Emulsion is a biphasic dosage form in which two immiscible two immiscible liquids are mixed, one of which is distributed throughout the another in a minute globules, and the system is stabilized by addition of third substance known as emulsifying agent. Let's see once again. Emulsion is a biphasic dosage form in which two immiscible liquids are mixed, one of which is distributed throughout the another in a minute globules, and the system is stabilized by addition of third substance known as emulsifying agent. These are the very simple definition of emulsion. Next, types of emulsion. There are only two types of emulsion. First, oil in water, and second, water in oil. That means O by W or W by O. Let's see once. First, oil in water type of emulsion. In this type, the oil is dispersed phase and water is a dispersion medium. That means quantity of oil is less and quantity of water is more. In this type, the oil is dispersed phase and water is a dispersion medium. These are the oil in water type of emulsion. Second, water in oil. That in this type, the water is dispersed phase and oil is dispersion medium. In this type of emulsion, water is in low quantity or oil in is more quantity. These are the only two types of emulsion, oil in water and water in oil. Identification test of emulsion. There are four tests for identification of emulsion. First, dilution test. Second, staining test. Third, electric conductivity test. And fourth, fluorescence test. Let's see. First, dilution test, staining test, electric conductivity test, and fluorescence test. Let's see once one by one in detail. Dilution test. The principle behind this test is that unlimited addition of dispersion phase into emulsion does not break the emulsion, but addition of disperse phase will break the emulsion. What is dilution test? The principle behind this test is that unlimited addition of dispersion phase into emulsion does not break the emulsion, but addition of disperse phase will break the emulsion. Example, in oil by water emulsion remains stable upon unlimited dilution of water, but unlimited addition of oil will break the emulsion. Second, in water by oil emulsion remains stable upon unlimited dilution with oil because of oil is a dispersion medium and water is a disperse phase, but unlimited addition of water will break the emulsion. These are very simple tests. Second test, staining test. This test can be performed by using either oil soluble dye, that is scarlet dye, or water soluble dye, that is safranin. These two dyes are used for performing staining test of emulsion. During the preparation of emulsion, triturate scarlet dye with emulsion. Take a drop of such emulsion on a glass slide and observe under the microscope. There are two possibilities. If red dispersed globules are seen on a colorless background, then it is a oil by water type of emulsion. Let's see carefully. Red, red dispersed globules are seen on a colorless background, then it is oil by water type of emulsion. And second possibility is colorless dispersed globules are seen on a red background, then it is water by oil type of emulsion. Hot staining test. This test can be performed by using either oil-soluble dye, that is scarlet red dye, or second, water-soluble dye, that is safranin. During the preparation of emulsion, triturate scarlet dye with emulsion. Take a drop of such a emulsion on a glass slide and observe under microscope. If red dispersed globules are seen on a colorless background, then it is oil by water type of emulsion. Second, colorless dispersed globules are seen on a red background, then it is water by oil type of emulsion. That is staining test. Third, electric conductivity test. The principle behind this test is that water conducts the electricity while oil does not conduct the electricity. Thus, in oil by water type emulsion will conduct the electricity because water is in the continuous phase or dispersed medium. Or second, water by oil type of emulsion will not conduct the electricity because oil is continuous phase. These are very simple tests. Fourth, fluorescence test. Many oils when exposed to UV lights give fluorescence. Many oils when exposed to UV light give fluorescence. Is a drop of such emulsion is observed under microscope using UV light, and if entire field gives fluorescence, then it is water by oil type of emulsion because oils when exposed to UV light give fluorescence. Thus water does not give UV light exposed to UV light and does not give fluorescence. If emulsion shows spotty fluorescence, then it is water by oil by water type of emulsion. That is fluorescence test. These are the four identification test of emulsion: fluorescence test, electric conductivity test, staining test, and dilution test. We see in detail. Next point, emulsions or emulsifying agents. What is emulsions? Definition: the agents which stabilize the emulsion are called emulsifying agent. The agents which stabilize the emulsion are called emulsifying agent. Classification: there are naturally occurring or semi-synthetic or synthetic type of emulsions or emulsifying agents. Let's see in detail. Naturally occurring emulsifying agents. First, plant sources such as acacia, tragacanth. Say B, animal sources, that is beeswax, gelatin. Third, mineral sources such as bentonite, magnesium oxide. These are all the naturally occurring emulsifying agents. Second, semi-synthetic emulsions. Example, polysaccharide, methyl cellulose, ethyl cellulose, etc. come under the semi-synthetic type of emulsions. And third, synthetic type of emulsions or emulsifying agents. There are again four types: anionic, cationic, non-anionic, and ampholites. Let's see examples of in detail. Anionic, soap of divalent metals, sodium lauryl sulfate. In cationic, cetrimide, benzalkonium chloride. Third, in non-ionic, twins. In D, ampholites, dodecyl alamine. These are the example of synthetic emulsions. Ideal properties of emulsifying agents. What properties should emulsifying agents have? First, it should be surface active. Second, it should reduce surface tension below 10 dyne per centimeter. It should be adsorbed quickly around the dispersed phase globules by forming a complete coherent film. Fourth, it should increase the viscosity of emulsion. Fifth, it should be non-toxic. Sixth, the odor and taste should be compatible with the preparation. Seventh, it should be chemically compatible with the other ingredients of the preparation. And these are the some ideal properties of emulsifying agents. Must have. Or this should be surface active, should reduce surface tension, etc. Next point, methods of preparation of emulsion. There are two methods: wet gum method and dry gum method. Let's see first wet gum method. In this method, mucilage of acacia is made. First, primary emulsion. Triturate a procedure of primary emulsion. Triturate acacia with twice the quantity of water. Triturate acacia with twice the quantity of water as that of acacia in mortar to form a mucilage. Measure out required quantity of oil and add dropwise into the mortar with titration in one direction until primary emulsion is formed. The crackling, that is chit chat sound, indicates the formation of primary emulsion. These are a very simple method. Primary emulsion. What we do? First, triturate acacia with twice the quantity of water. If we take acacia 1 gram, then we take water 2 ml. After in a mortar for hot purpose, because of formation of mucilage, measure the required quantity of oil and drop twice into the mortar. How many times? For the primary emulsion form, that is crackling sound is not formed, that is crackling means chit chat sound. Second, dilution of emulsion. Emulsion is diluted up to prescribed volume by adding slowly the external phase with trituration. These are the wet gum method. Difference between wet gum method and dry gum method. These are very important questions for asking any times MSBT or UPBT in final exams for 3 marks or 4 marks. What is wet gum method and dry gum method? Let's see. In wet gum method, mucilage of acacia is used. In dry gum method, dry acacia is used. In wet gum method, oil is added dropwise. In dry gum method, whole quantity of oil is added at a time, not a dropwise. In wet gum method, third point, primary emulsion is viscous, that is creamy in nature. In dry gum method, it is thick and oily in nature. In wet gum method, it is relatively slow process. In dry gum method, it is quick process. In wet gum method, all apparatus are not required to be dried. All apparatus are not required to be dried because it is wet gum, not a dry. In dry gum, all apparatus should be dried like mortar, pestle, etc. Next point of this chapter, instability in emulsion. There are three instabilities of emulsion, which of the these are the following. First, creaming in emulsion, cracking of emulsion. Third, phase inversion or phase reversal. Let's see one by one in detail. What is creaming in emulsion? Creaming is nothing but the formation of relatively concentrated layer of emulsion from the original. Creaming is nothing but the formation of relatively concentrated layer of emulsion from the original. Cream emulsion can be performed by shaking because cream is relatively concentrated layer of emulsion. This layer can be broken into small globules by shaking. The creaming will take place at the top or the bottom depending upon density of the dispersed phase. Are you understand what is creaming in emulsion? That means cream layer is formation upside or downside the bottle or container for emulsion. Creaming is nothing but the formation of relatively concentrated layer of emulsion from the original. Cream emulsion can be performed by shaking because cream is relatively concentrated layer of emulsion. This layer can be broken into small globules by shaking. The creaming will take place at the top or the bottom depending upon density of dispersed phase. Second, instability, cracking of emulsion. In creaming, there is cream formation. In cracking, there is crack formation. Cracking of emulsion means separation of dispersed phase as a separate layer which is not redispersible upon shaking. Cracking of emulsion may be caused by changes in the nature of interfacial film of an emulsifying agent, because cracking of emulsion is formed because of a uh, unquantity of or wrong quantity of emulsifying agents we added. Third, phase inversion. The phenomenon of conversion of oil by water type of emulsion into water by oil type of emulsion is called phase inversion. Let's see, it is very simple. Phase conversion means oil phase is converted into oil phase or water phase is converted into oil phase. That is conversion of dispersed phase into continuous phase and continuous phase into dispersed phase. The addition of any substance that alters the solubility of emulsifying agent may cause phase inversion. Why phase inversion is formed? Because of the addition of any substance that alters the solubility of emulsifying agent may cause phase inversion. These are three instability of emulsion. Next, final important topics, HLB. HLB means hydrophilic lipophilic balance and its importance. What is HLB? HLB means hydrophilic lipophilic balance. Generally asked in question, give the long form or abbreviation of HLB. What is abbreviation? HLB means hydrophilic lipophilic balance. History of HLB. Griffin, scientist, in 1949 devised a useful method for calculating balanced mixture of emulsifying agent to provide a particular type of emulsion, which is called HLB method. Surfactant molecule, that is emulsifying agent, shows two parts. First, hydrophilic parts. Hydrophilic. Hydro means water and philic means loving. That means affinity towards water. In simple language, I say hydrophilic means water loving, or second, lipophilic means lipid loving. In scientific language, affinity towards oil. Generally, emulsion having HLB numbers below 9 produce water by oil emulsion. 9 to 11 are intermediate. Above 11 produce oil by water type of emulsion. These are the very simple HLB. Are you understand what is HLB? HLB means hydrophilic lipophilic balance. There are two types emulsifying agent. Hydrophilic means water loving, and lipophilic means oil loving. Generally, emulsion having HLB numbers below 9 means water by oil emulsion. 9 to 11 are intermediate. Above 11 produce oil by water type of emulsion. Importance of HLB scale. It plays an important role in formulation and stability of emulsion. It has a value in non-ionic type of emulsions. It is useful for selecting emulsifying agents. It is useful to avoid the problems like creaming and cracking. These are the four importance of HLB scale. Generally in exam, asking the question, define HLB or give a short note on HLB, or like that, define HLB and give its importance. You must require write down the HLB definition, some history, their types, generally having HLB numbers and importance. So friends, thank you guys for watching this video till the end. So friends, if you're new on this channel, so please like, share and subscribe to our YouTube channel for pharmacy related daily videos. Generally, I uploaded this channel pharmacy related, specifically D pharmacy first year or second year. So friends, please don't forget the subscribe our YouTube channel. Let's see once again what we see in today's video. Just by quick revise. Importance of HLB scale. It plays important role in formulation and stability of emulsion. It has a value in non-ionic type of emulsions. It is useful for selecting emulsifying agents. It is useful to avoid the problems like creaming and cracking. HLB and its importance. HLB means hydrophilic lipophilic balance. Three, instability. What is the instability? Creaming in emulsion, that means cream formation is occurring upside or downside the emulsion or container. Cracking means there is a separation of layer. Phase inversion means oil is converted into water phase, and continuous phase is converted into disperse phase, or disperse phase is into converted into disperse phase. Difference between wet gum method and dry gum method. These are very important questions about the topic. Method of preparation, wet gum method and dry gum method. Ideal properties of emulsifying agents. There are classification of emulsifying agents or emulsions. Emulsions means the agents which stabilize the emulsion are called emulsifying agent. There are four tests of identification: test of emulsion, dilution test, staining test. In staining test, there are safranin or scarlet red dye test. Scarlet red dye we use. Types of emulsion, there are only two types: oil in water and water in oil. Emulsion definition. Topics we are in today's video, we cover these topics: definition, emulsion, emulsions, types of emulsion, identification test of emulsion, emulsions and their classification, methods of preparation of emulsion, instability in emulsion, HLB and its importance. So friends, thank you, bye bye, and let's see in next video.